Hello, Math068. We are on section 15. We are converting values between the normal and the standard normal distribution. All right, so what does that actually mean to us? A lot of mathematical jargon there for something that should be pretty easy. So if we take a normal curve and we distribute mu, center, some standard deviation value. And that standard deviation can be anything, remember? The center can be anything we want it to be, and the standard deviation can be anything we want it to be. So we very well could have a center or a mu value of 18 with standard deviations of 2, which would put me at 20 and 22. Well, what we want to do is we want to say, you know what? I don't really understand 18 moving over 2 or moving down 2 and things like that. And I'd rather standardize this. I'd rather take all data and put it on what we refer to as a standard normal distribution. Well, standard normal distributions are always centered at a 0, and they all have a standard deviation of 1. We refer to this as a Z distribution or a Z standard normal. All Z values are on a standard normal, centered at 0, and moving up and down the scale by 1. Very easy for the mind to support. We will need a formula for this. Formula for this is going to be to go from a normal distribution to a standard normal distribution to calculate what we're going to refer to as the Z-score. The Z-score. The Z-score is going to be on the number line, some Z value. We're going to take X. X is our data value that comes from the normal distribution. We're going to subtract the mu value. Well, the mu value also has to come from the standard or the normal distribution. We're going to divide it by the standard deviation. So whatever the standard deviation is, again, of the normal distribution, we're going to pile all that into a formula, and when we spit it out, it's going to give us a number Z, and this Z number, change my color so we can alternate between, is going to be this value. Maybe plus Z, maybe minus Z, depending on if we're on the left or the right-hand side of the mu value. And the mu value will always be 0. So let's see what this looks like in practical practice. It says Z-scores are a way to compare a normal population. Okay. It says, suppose that we know someone's weight is 150 pounds. So we know that we have a 150-pound weight. So it might be good information, but if we want to compare it in an average person's weight, we look at the vast table that we can be overwhelming. So we want to put this into a standard normal. It says that the Z-score, that's the number of standard normal distributions away from a center that we are, of a person's weight to compare it to the population's mean weight. Remember, the population mean weight on the standard normal will be 0. It says values of X that are larger than the mean have positive Z's, and values of X that are smaller than the mean have negative Z's. So in our formula, it says, for example, let's say that we know that we have a data point value of 6.2. This is a normal value of 6.2. We are centering, or we have a mu value of 5. The standard deviation of my data is 10. And I'm not pulling this from anywhere right now. I'm just giving this as an example. What would be the appropriate Z-score for a data statistic of 6.2 on a curve that was at a 5 if it was deviating 10 points each way? Well, the Z would be approximately 0.12. What does that 0.12 indicate to me? Well, if you look at the picture below, it says if you used to have a data point 6.2 on a normal distribution, you will now have a Z of 0.12 on a standard normal distribution. We like to put things on a standard normal distribution because I really don't know where 6.2 is in relationship to 5, but I do know that 0.12 compared to a 0 is less than 1 standard deviation away. Remember that on a standard normal, The center is mu, 0, 1 standard deviation, 2 standard deviations always, -1 standard deviation, -2 standard deviations always. So I know where 1.2 falls on that 0 curve. We're going to go down to the student exercises, and we're going to produce a couple of these. And all this time, we're going to use the formula z is equal to x minus mu divided by the standard deviation. It says we'd like to have the area below 71 on a normal distribution. And we'd like to have a mean of 40 and a standard deviation of 15. All right, well, we're going to start with, on the left-hand curve, we're going to start with the standard distribution, okay? So we're going to start, because we have a mu value of 40, we're going to start with 40. We know that our standard deviation is 15, so right away, 55, and I'm going to move to 70. I'm going to go down to 25, and I'm going to go down to 10. Remember, it said the area below 71. So I'm going to find 71, which is about right here, and I'm going to shade all of that area in. That's a whole lot of area. Now what we're going to do is we're going to calculate the standard normal, or the z-score, for this data. We're going to get a z-score. So we're going to take our data statistic 71. We're going to subtract our center, our mu value of the original data of 40, and we're going to divide it by the standard deviation, which was initially 15. It matters that 71 minus 40 because that produces a positive number. When you do that math, you get a 2.07 value, positive. Now we're going to redraw the standard normal curve, always at 0, 1, 2, -1, -2. We're going to put our z-score in of 2.07, which is, again, just barely above the 2, and we're going to shade everything below it. These two curves are absolutely positively equal. They contain the same p-value. The p-value of this one equals the p-value of this one. And there is no difference in them. Then you might ask, why bother? Because if I look at the right-hand side value, I can clearly see I am outside 2 standard deviations. That tells me that I am not in the normal position of the 95% data curve. Go back several chapters. Remember, under 2 standard deviations is very normal. Not under 2 standard deviations is not normal. So let's do a couple extras here. It says we want the area above a 90 on a normal distribution with a mean of 100 and a standard deviation of 50. Let's draw in our first number here. Let's draw in our 100, and let's up and down it. There's 115, there's 130. There's 85, there's 70. We want the area above a 90. All right, well, here's 100, here's about a 90-ish, and we want the area above. What we want over here, and we can start the chart, we want a 0 and a 1 and a 2. We want a -1, we want a -2, and what the z-score, or the statistic, for the standard normal. The z number is your data that you were given, 90, minus your middle, 100, divided by your standard deviation, which was 50. You should notice now you're going to get a negative value, and your z value is negative 0.67. We go by and find 0.67, which is approximately here, and we shade everything to the right. Completely normal value because I am within, actually, 1 standard deviation to the left. I am very close to what I feel is the center of this data. Letter C, the area between 7 and 9 on a normal curve. All right, so we have a mu of 5. We have a standard deviation of 1.2, 6.2, 7.4. Could keep going if I needed to. I can go below at 3.8 and 2.6. My data value is between a 7 and a 9, all right? Well, 9 is way out here, and 7's about here, so somewhere about here. We're going to do a data statistic on Z, but can you notice that we're going to need two Z values? We're going to need a Z value for right here, and we're going to need a Z value for right here. So let's do the first one. Let's take the Z value of 7. That's our data point. Let's subtract our middle, which is 5. Let's divide by our standard deviation of 1.2, and let's get 1.67. Then let's do our right-hand side Z value. We're going to take the other value. And the other value was 9. We're going to subtract the 5. We're going to divide by 1.2. And when we're done, we're going to get 3.33. Now we can put those into our data chart or our standard normal. 0, 1, 2, 3. My first number is 1.67, about right here. My second number is a little over 3, and my area p-value is exactly equal to my opposite p-value in the non-standard normal. Letter D. It says, assume that the cholesterol levels for men in the United States are normally distributed with a mean of 215 milligrams per decibel. All right. Deciliter, sorry. So the center of my first value is 215. And I have a distribution of, I need my distribution here. I don't have a standard distribution. So I'm going to give you one. Got to have a standard distribution. There's no getting around that. So let's say that we don't have it sitting on here, and I'm going to tell you it's 15, because that's been normally what we've been doing. Somebody must have forgot to type it. I have 230. If I go downward, I have 200. I could go down another one, 185. Let's see where that makes us land at. I think I have to go further. I'm going to go down to 170. So it says that 215, it says we want to know levels less than 175 right there. All right, well, 175 is here, and we want to have all values smaller than 175. Very small tail to the left side. Let's do the Z value for this. So let's take a Z statistic. Let's take the 175 data point. Let's subtract the mu value of 215. Let's divide that 215 by what I put in to be standard deviation of 15, and negative 2.67. How did I know it was negative? Because the other data point was on the left. Sorry, I was getting paged over the PA there. So the middle is always going to be 0, 1, and 2, negative 1, negative 2. We almost have to go out to negative 3 because we're right in the middle of that at 267, and our new Z point shows left tailing more than 2 standard deviations to the left-hand side. Last part for this particular chapter, or this section, I should say. So it says to transform a Z-score to a standard value, we'll use a separate formula. This separate formula says you can find the X statistic. Remember, that's the statistic. If you take mu, where you want the center to be, and you add the Z-score times the standard deviation. Okay, so it says on the first question, find the X value for the housing price when the housing's Z-score is 2.5. So first of all, we know this is a right side number because it's positive. For the average mean of a house in the area is 280,000. And the standard deviation is 12,000. So we know the standard deviation, 12,000 each, and we know that the center is 280,000. Our x value will be equal to mu, the center of the data, plus the z-score, 2.5, multiplied by the standard deviation of $12,000. Our x statistic will be $310,000 on the normal distribution, or on the standard distribution. The standard normal was the z-score. We are finding the x value, which is just on the normal distribution. Remember, the word standard will always indicate a z-score. Last one. Find the x value for an exam when the z-score is 1.8 and the average mean is 70 if you have a standard deviation of 50. Test score x equals 70, because that's my mean, added to my z-score, 1.8, multiplied by my standard deviation, 15. The score that I would expect to receive on the test was 97 on the standard distribution.